Module 3 will look at the notion of variables, assignments, and how operators in C works. So let's take a small problem again. This is a problem on polynomial multiplication. Let's say we are given two polynomials ax plus b and cx plus d. So by given, what I mean is you are given the coefficients a comma b, and you are also given the coefficient c comma d, and you are expected to compute the product of the polynomials. So the product would be ac x squared plus ad plus bc times x plus cd. So what we really want is the coefficient of x squared, the coefficient of x, and cd itself. So to write a program for this problem P 1.1, we need the following steps. So we need to declare storage. A, B, C, D are all coefficients. If you read from the user, you need to store them temporarily somewhere. And once the declaration is done, you need to actually read the coefficients from the user, perform all the arithmetic operations required, and finally print them on the screen. So that's the basic steps. So I already have a small program written up here. So we start with declaration of storage, that is step 1. So again, ignore the first few lines. You see that there is int a comma b comma c comma d and int p2 p1 p0. So this is very much like what we did earlier. So we have a b c d, so we need 4 coefficients, and the product, the polynomial, has only 3 coefficients, p2 p1 and p0 is the name that I am giving them. Step 2 is read the inputs. So in this program I have written it in such a way that it will prompt the user for one coefficient at a time. So there is printf enter a, and the user is expected to enter a number, and it is read using the statement scanf. Then you have printf enter b, now you are ready to read b, and so on. So 4 coefficients are read. So this is step 2. Step 3, calculate the coefficients and print. So here there are 3 lines, p2, p1 and p0. p2 is a times c, p1 is a into d plus b into c, and p0 is b into d. So this is the very first time you are seeing an assignment. So the way to look at assignments is, look at the equality sign in the first line here. You see a star c, so star is the operator for multiplication. So you are multiplying a with c, and that is assigned to p2. So the way to look at this line is, you do the operation a times c and the value is assigned to p2, which is on the left side. Then you have a times d plus b times c. So you do this operation and you assign it to p1, and b into d is assigned to p0. So at the end of these 3 statements, we expect p2, p1 and p0 to reflect the point that you have already taken care of the multiplication of the polynomial. And now you are ready to print, and the product is printed on the screen. So again, forget all the fancy looking things there. So you can see that printf, the product is, and something there. So ignore it for now. It's only printing the coefficients along with the in the polynomial format itself. So let's run this program. I have written this program up, and let's run this program. So you can see that the program is the same as what I said. So you have int a comma b comma c comma d, then you have the 3 coefficients p2, p1 and p0, the 4 scan statements for reading the variables, 3 statements for doing all the assignments or doing the arithmetic operations, and 1 final statement which takes care of printing. So I will compile it now. It gives me no errors or no warnings. So far I have not shown you what errors and warnings could be. I have written programs which are all correct. Now I am ready to run. So as before, we see the value prompt for a. So I am going to enter the polynomial 1 comma 2. So essentially 1x plus 2 for the first polynomial and 3x plus 4 for the second polynomial. So the result is 3 times x squared plus 10x plus 8. So it's 1x plus 2 times 3x plus 4. So that is 3x squared plus 10x plus 8. So let's look at the program in its entirety. We have the first few lines which has the comment. So there is a comment on the top here which says this is a program to multiply two polynomials ax plus b and cx plus d. So it's always good to show the intention of the programmer, and this kind of documentation is helpful for somebody else who is going to read your program and understand what is happening. Then as before, we have this line hash include stdio.h. This is necessary for doing all the IO operations. If you want to read from the keyboard or if you want to print on the screen, you will need this. And then we have the declarations for A, B, C, D, P2, P1 and P0. Then we did a series of printing on the screen and reading from the user, and we did the operations and printed the result on the screen. So I already showed you the executions. So this by itself is not what I want to show. I want to drive something else. Let's take a close look at the program and see some of the nitty-gritty details that are involved. So let's start with a comma b comma c comma d. So I assume that the polynomial is ax plus b and cx plus d. So however, we need the user to give these four coefficients, and these four coefficients have to be taken from the user and stored temporarily somewhere, and that's where we are going to use these variables a, b, c and d. So in a little while I'll explain what the word variable means. At this point, just assume that a, b, c and d are four variables, and it's not enough to just have these coefficients because you are supposed to produce the product terms. So you have a, b, c, d and you have p2, p1, p0, and when you have int a comma b comma c comma d, it actually allocates storage for a, b, c and d, because once you read it from the user you have to save it somewhere. And when you have p2, p1, p0, again you allocate the storage for p2, p1, p0 and store it somewhere. So essentially it takes care of all the storage that you need to do all the operations, and this storage is going to be in the main memory. So we already saw the model for the computer. So we have memory and we have a CPU and we have other units. So these variables will be stored in the memory. And if you look at this int basically means that int stands for integer, and it means that anything that follows this is going to be a variable which is of an integer type. So when you have int a comma b comma c comma d, we have four integers or four variables of the data type called integers. Similarly, we have p2, p1, p0 which also have this int before it, which means there are three integers by name p2, p1 and p0. So if the input coefficients a, b, c, d are all integers, the product and sum of integers are always integers. So therefore I have used integer for p2, p1, p0 also, and this is called the data type. So whenever you want a variable, it cannot be a variable of an unknown type, it has to be a variable of a known type, and there are a few basic data types that the language provides you. There are other data types that you can build on your own. In this case I am going to use basic data type provided by C, which is called int. So remember, int stands for integer. Now let's see what is going to really happen from the memory point of view. So let's see the program. So initially the memory is unused. I'm showing a segment of the memory here. So let's assume that the memory is huge and it has several bytes of storage. I am showing only a portion of the memory on the right hand side. So initially everything is unused, and the moment there is a declaration int a comma b comma c comma d, what it really means is when you run the program, there are going to be four memory locations which will be called by the names a, b, c and d. So the memory that you have is initially uncommitted. The declaration int a comma b comma c comma d will attach some names to the memory locations. So in this example, this memory location is going to be called A, this memory location is called B, this is called C, and this location is called D. So I am purposely showing these locations without any values, because when you declare, you should not assume that there is going to be some known value already present in the memory. So when you start the program, we don't know what the values are, and that's we also expect the user to input these values A, B, C and D. And the next line was int P2, P1, P0, which means there are going to be 3 memory locations which are going to be called P2, P1, P0. So in this picture, even though it shows A, B, C and D to be continuous and P2, P1, P0 also to be contiguous, it does not necessarily have to be so. So they do not have to be contiguous memory locations. So we have this. So we looked at the first few lines of the main function, and all it does is it is declaring storage. So you are saying various memory locations are going to be called by these names. Now let us look at the statements that follow. So we have printf enter A, and let us say it prints this enter A on the screen, it is prompting the user, and when it comes to scanf, it is going to read one number from the screen. Let us assume that the user actually input 1. So we assume that the polynomial is Ax plus B is 1x plus 2 and Cx plus D is 3x plus 4. So at this point the user is expected to have entered 1, and that would go into the memory location which is called A. So 1 goes into this memory location, then printf enter B, that will show enter B on the screen. When the user inputs B, in this case it is 2, that would go into this memory location, and so on and so forth. So at the end of all the scanf statements shown here, if the user entered 1, 2, 3, 4, these locations would contain 1, 2, 3, 4. P2, P1, P0 I am showing blank. It does not mean that it does not have any value, it only means that we do not know the value yet, it has to be calculated yet. So at this point A, B, C, D are all ready and is available in the program. So let us move to the next set of statements. The next set of statements are for calculation of P2, P1 and P0. So remember in this computers model I showed a control unit which contained the CPU which contained a control unit and the ALU. You had memory. So in this, at this point I am showing the memory and the ALU, I am not showing the input and output and other nodes and so on. So ALU stands for arithmetic and logic unit, and since we need arithmetic operations here like multiplication, addition and so on, I am also showing the ALU. So let us see the very first statement here. P2 is A times C. So this star means multiplication. So what you want is A and C to be multiplied, and the result of that must be stored in P2. This is what you want, and the way it works is this. So when you have P2 is A times C, A and C are brought in from the memory into the ALU. The ALU does the operation multiplication, in this case it is 1 times 3, and the result 1 into 3 which is 3 is written back into P2. So if you look at this statement, you read the value of A which is 1, you read the value of C which is 3, you do multiplication, the result is 3, and the result is written back in the memory location P2. So which is what we have so far. We read 1 and 3 and the result is 3 here. So now we are ready to move to the next statement. The next statement is slightly more complicated. It has a star, it has a plus and it has another star, and the order in which the operation is done is you perform the operation A times D first, you then perform the operation B times C, the result of these two are then added up and the result will be, the end result is put back into P1. So that is what we are going to see in the animation now. So A and D are both read into the ALU, and it is not ready to be written back to P1 yet because you still have more operations on the right hand side. So this 1 times 4, the result is 4, it is temporarily stored inside the ALU itself. Then you have B times C, B and C are read from the memory and the result is 6, so 2 times 3 is 6, and you cannot write 6 to P1 yet because this is also a temporary result. What we really want is A times D plus B times C. So we cannot write 6 to the memory yet. At this point the ALU has 4 and 6 which are required for this addition operation to be performed. So, if you have only one of these operations, let us say A times D was available, but B times C was not available, then the addition cannot be performed. But at this point of time you have both 4 and 6, and 4 plus 6 is executed by the ALU, the result is 10, and once you have the result you are ready to write it back into P1. So, the RHS or the right hand side is ready, we have the result and we write the result into P1. Next the CPU moves to the last line, which is P0 is B times D. So, again B and D are brought from the main memory in this time. So, B and D did not change, they are 2 and 4, and the result of that is written back into the main memory. So, at the end of the program we have 3, 10 and 8. So, let us take a quick look at the program here. So, what we saw was these 4 or these statements from line number 10 to 17 initially filled up the 4 memory locations A, B, C and D with values by reading from the user. Lines 18, 19 and 20 did operations, the user is not involved here, the values from the memory are read and the calculations are performed, the results are written back into the memory, and finally when line number 22 is executed, it is asking P2, P1 and P0 to be printed on the screen in a certain format, and the way it is going to be printed is as follows. So, you have the product is percentage D x squared plus percentage D x plus percentage D backslash n. What that means is, so if you look at this percentage D and if you run this program, you will never see this percentage D on the screen. So, I enter the same thing, if you see the result, the product is only 3x squared plus 10x plus 8. What it's really doing is, this percentage D is called a format specifier. So, wherever you have percentage D here, you look at what is the value outside the quotes. So, it says print P2 as integer, that is what this percentage D means. So, P2 is an integer, print it as an integer, P1 is also an integer, print it as an integer also, and P0 is an integer, print it as an integer also. So, that is why you get this result 3 times x squared plus 10x plus 8. This x caret 2 or x squared is verbatim in the program itself, and this x plus is also verbatim in the program, you see that in the result here, and finally 8. So, we will get into the format specifier and so on in more detail later, but as of now just remember that this percentage D is not something that is printed on the screen. So, to print something on the screen you need P2, P1, P0 stored in the main memory, but we have them as 3, 10 and 8. So, when you see the printf statement you can read these 3, 10 and 8 and print them on the screen.